So let's talk about mean and standard deviation. So mean or average is often denoted by the letter mu, which is a Greek letter. Mathematicians kind of ran out of other letters, so we started using Greek. Okay, and all that means is we're taking the average number of a certain set of numbers. So for example, let's say that we had a set of grades. Right? We had, say, on a test, we had some kids who got 33%, maybe another that got 44%, somebody just passed with a 50, maybe a couple of kids came pretty close, maybe a 70, and a couple more that did pretty well, 82, 87. Okay, so let's say that this is our data set, these 1, 2, 3, 4, 5, 6, 7 values. Okay, to find the mean, the average of these values, we use this formula. So the mean equals the sum of all terms. Right, this little symbol is called sigma. It just means sum, which just means add things up. And that's divided by the number of terms. Written out as math here, we'd have the sum of all terms, so 33 plus 44. We're basically just adding up all of the terms above, plus 50 plus 52 plus 70 plus 82 plus 87. So we add up all of these 7 terms. Then we divide by however many terms we have. So in this case, we have 7 terms. So we divide by 7. So we add all of those up. So it gives us a total of 418. Whoops. Divided by 7. Okay, so we take our 418 divided by 7. We get 59.7. We'll cut it off there. Right, so our average grade was 59.7%. Not too bad. Okay, so that's the mean. That's the average. That's just finding kind of the value that best represents the spread of these values. But how good is this average? How do we know? Well, to find how good that average is, we have to find the standard deviation. Okay, and standard deviation is just a little bit more complicated, but not too bad. It's denoted by this little symbol here. A little bad at drawing them, but it's a bit of a flat O with a tail. That's actually just a lowercase sigma. Same letter, lowercase. Okay, again, mathematicians. We run out of letters really quickly. Okay, so the formula on this one is a little bit different, and I like to do it in several steps, but I'll show you the total formula first. Okay, so I'm going to write it out. It's going to look a little confusing, but we'll go through it. So it is sigma equals, so standard deviation equals the square root of the sum, whoops, not an E, a sigma, the sum of each term, we call them xi, it just means that there's several of them, right? So term 1, term 2, term 3, minus the mean. So that's the difference between the term and the mean, squared. And then that is all over the number of terms, n. Okay? So just to write this out here, so xi is our terms, mu is our mean or average, and n is our number of terms. Okay? So this looks a little bit confusing, and the work can be a little bit long. But if we take it step by step, it's not too bad. So let's give that a shot. Okay, so new page just to get us some more room here. So step 1 is going to be find the difference between the term and the mean. So write difference between term and mean. Or in other words, we're just going to subtract the mean from each term. So subtract 59.7 from each and every one, right? This is what I mean when when I say that this kind of calculation can get a little bit long. It's a lot of really simple steps, and as long as you do them in the right order, you should have no problem. But it is a lot of steps, and it is a lot of terms. So if you have a lot of terms, it takes a while. Okay, so we take each of these. I'm just going to do a couple of them, and then I'll do the rest off screen because I'm not going to waste your time here. But 33 minus 59.7 gets us negative 26.7. And the next one we get a similar thing, 44 minus 59.7. We get negative 15.7. These can be positive or negative, as you'll see as I go through all these. So I'm going to do the rest off screen, and we'll come back in just a moment. Okay, so there's all of our differences. So you'll see some of these higher scores, the difference was positive. Some of these lower scores, the difference was negative. The sign doesn't matter so much as how far apart these two numbers are. And the reason the sign doesn't matter much is because of our next step, which is number 2 here. We're going to square the difference. Right? Because when you square something, the sign disappears, or rather the negative disappears. It's going to be positive. Okay? So all this really does is it kind of magnifies the larger differences so that we get a better idea of how spread out these values are. Okay? So if we take the square of these values, the square of 26.7, or rather negative 26.7, is going to be a positive number, so it's going to be 712.89. If that's coming out as a negative number, your calculator is likely reading that negative incorrectly. Okay, so we just continue on like that. Again, I'll come back in just a moment. Okay, so there's all our squares. So we can see that the larger the absolute value of the difference, the larger the square should be, which makes sense because these values are further away from the mean, so they're much larger than the central values that are very close to the mean and have a much smaller squared difference here. Okay, so our next step is going to be to find the sum of all of these. So 3, sum the squares. Okay, so all that means is we're going to add all of these up. Okay, so when we add all of those up, we should get 2,461.43. Real big number, but that's going to shrink real soon. Okay, so that's the sum. Our next step here, number 4, we are going to divide by the number of terms. Whoops. Spelling errors. Terms. There we go. Okay, so remember we had 7 terms. We take this total sum and divide by 7. Okay, so again, that is the number of terms, so we can even just count these 1, 2, 3, 4, 5, 6, 7 to be sure. Okay, once we've done that, we just take our number here and we divide by 7, and we will get 351.6. Okay, now we've just got one more step here, and that is, we'll say number 5 in black here, take the square root. Okay, so taking a square root is like undoing a square, and it's this little symbol here, this little check mark. Okay, so when we take the square root of 351.6, we'll end up with our final number of 18.8. Again, just rounding to that 8 there. Okay, which means that our sigma is 18.8. Okay, now we've now got a measure of how good this is, but what does it really mean? Well, if we want to kind of look at that, just separating this off a little bit, like what does it really mean? We can write it in the form of the mean plus or minus sigma. So what that means is that the range of values falls roughly within this standard deviation, right? And we'll look into later about distribution and how to look at a normalized distribution, that sort of thing, but just writing it this way, our mean was 59.7%, and then we do plus or minus our sigma, 18.8%. And what that means is the typical value in this set falls between that much up and down that value. And you might start thinking, well, that's like a third of this entire value. So that probably tells you that these values are quite spread apart, right? The smaller this value is, the smaller that range is, the closer everything is to that mean. Okay, so that's why we do this mean and standard deviation, is so that we can see how close this value is to all the points by seeing how large this number is in comparison. Okay, so we'll do lots more applications of mean and standard deviation as we go forward, but these are kind of the core skills for mean and standard deviation.